Good morning, dear students. Once again, we are here to discuss our DOE Worksheet 30, scheduled 11th September 2020 from your chapter Motion. And today we will discuss velocity. What is velocity and how it is different from speed? Speed of an object in a particular direction is called velocity. As we have discussed earlier in our previous worksheet also, velocity is a vector quantity and all vector quantities must have a particular direction. Okay, so speed of an object in a particular direction is called velocity. Like speed, it is also represented by v, right? And it shows the direction of motion of an object along with its speed. For example, if I say that a car is moving with the speed of 60 km per hour, then it is called as speed because I said only 60 km per hour. A car is moving with this speed. Okay, so this is speed. But if I say a car is moving with the speed of 60 km per hour in particular direction, say north, east, south, west, whatever, then it is said to be velocity. Then it is called as velocity. Okay, I hope you understand it. So, velocity of an object can be determined by the equation displacement divided by time, whereas speed is equal to distance upon time taken. Okay, and velocity is equal to displacement upon time, right? And as I told you, it is a vector quantity because it has both the magnitude as well as direction. Those quantities which have magnitude and direction, they are called as vector quantities. Okay, so vector quantities whose magnitude changes with the change in the speed and direction. And SI unit of velocity is also meter per second, right? But it can be zero. It can be zero. For example, see, because it is displacement, we considered it displacement upon time. Because this displacement is zero as well as negative, so velocity can be zero, right? Let's say an example. If this is your school and this is your house, and the distance between your school and house is say 20 meter, right? And you start coming to your school by covering the distance of 20 meter, right? And after that you move to your house. So again you travel 20 meter in the same path, in the same pathway. So students, in this case, first you covered in this direction 20 meter, then again you covered in opposite direction with the same path, so minus 20. So it seems to be out 20 minus 20, 0. So that is why we say displacement, because you started moving with the reference point from your house or from your home, and again you reach to your home, so displacement is 0, net movement is 0. So in this case velocity is also 0. So let's take the example. If you cover a distance from your home to school and back from school to home by the same route, say 10 meter, I took 20 meter, they have taken 10. In this situation you will have speed, but here the displacement is 0, therefore. And what is speed? See, you move, this is your school, this is your house, and we took 20 meter. You move from house to school, so we have 20. Then you move school to house, it is again 20. So the value of this in case of speed is 20 plus 20 divided by some time, whatever the given to you. So we have 40 divided by time. This is your speed. But in case of velocity, because you cover the same path in the same direction, so it is 20 minus 20, right, divided by t. So 0. That is why this answer is 0. Okay. Then when an object, so velocity is 0, and so when an object is moving along a straight line with the changing speed or velocity, we can calculate the magnitude of its rate of motion in terms of average velocity by the following equation. If an object is moving along a straight line, if I say that our car is moving along a straight line, but with a changing speed or velocity, in this time it is having, I mean, 10 meter per second, then it changes to, maybe due to some hindrance and all, 5 meter per second, then again it is, I mean, covered 15 meter per second, likewise. So it is changing, right? It is changing. So if an object is moving along the straight line with the changing speed or velocity, we calculate the magnitude of rate by initial velocity plus final velocity divided by 2, right? In that case we take average velocity. Keep in mind, in that case we take when there is change in, maybe it is increasing, okay, like 5, 10, 15 or whatever, right? Then we take initial and final, and then we add those velocity divided by 2, we'll get the average velocity, right? Then we have, when we do, okay, Gyan has next question. What? When do we say that an object is in uniform motion or not, right? And what happened to the velocity in that condition? Gyan has a question that when we say that an object is moving with a uniform motion or not, or a non-uniform motion, or what happened to the velocity in that case? See, Didi replied, if an object moves in a straight line, if an object is moving the straight line and covers equal distance, right? See, it covers equal distance in equal interval of time, say 5, 10, 15, 20 meter per second, meter per second, meter per second, meter per. So this is equal distance traveled in equal interval of time. Then we say it is a uniform motion. It is a uniform motion. Let this 5 meter cover in few seconds, whatever may be, and in next few seconds 10, next few second is 15, next few second is 20, then it is said to be a uniform motion. Okay, in this case velocity of an object remains constant. Velocity will not be going to change at all in this condition, because object is moving with the same speed. Okay, but if the object travel unequal distance, say here we have 5, next we have 7, next some hindrance is there, and maybe or maybe it is increased by 10 or whatever, this is unequal distance. Okay, when an object travel unequal distance in unequal interval of time, then is said to be non-uniform motion. In this situation the velocity will not be constant. Velocity will not be constant at all, it will change. So we have two type of, first accelerate, we have two type of motion. First accelerated motion, right? In this type of velocity, the object, we have two type of velocity. First accelerated motion, in this when the velocity of an object increases with the time, it is continuously increasing with increasing time, it is said to be accelerated object or acceleration. And when the velocity of an object decreases with time, it is called as retardation or negative acceleration. This is positive, this have positive value, and retardation is in negative, right? So let's take an example. A cyclist move from point A to B and covers 40 meter apart from each other, and then again comes back to point A 40 meter. Do so, then find the speed and the velocity. Okay, fine. First of all, we will find out speed. What is the time taken? It is 40 seconds, right? So first he covered A to B, he covered 40 meter. Then B to A, again 40 meter, right? So speed is equal to, we have distance upon time. Distance is what? 40 plus 40 divided by time, 40 seconds. So divided by 40, we have 80 divided by 40, 2 meter per second. This is your speed. Okay, this is your speed. See from this example, this is your speed. But in the case of displacement, or sorry, in the case of velocity, we have displacement divided by time. And student, what is displacement? Is the shortest distance covered by an object. So if in this cyclist move this A to B and cover 40, and then B to A covered again 40 in the same direction, but then we take this 40 in a negative value. So we have 40 minus 40 divided by 40 seconds, we have 0 divided by 40. And in the mathematics we know, when 0 is in numerator, the value become 0. So 0 meter per second. This is the case with the velocity. Okay. So this is all about your today's worksheet. Next we will do practice exercise. First we have differentiate between velocity and difference between velocity and speed. Student, speed is distance covered by an object per unit time, right? Distance covered per unit time is called speed. Speed is a scalar quantity. As I told you, scalar quantity, because it has only value, only magnitude. And this average speed never be 0. The value of the speed will never be 0. 0 or negative, right? But whereas in case of velocity, we have displacement upon time. So we call it as, that is the, when an object cover the displacement of an object per unit time is called velocity, right? It is a vector quantity because it has magnitude and both magnitude and direction. Okay, it can be 0 as well as negative. So this is all about your first question, velocity and speed. A car let's do second question. If a car travel 100 meter in 25 seconds, then find out the velocity. Velocity, we have 100 divided by 25, 4, that is 4 meter per second. This is the value of velocity. Okay, next, if a cyclist is going with the constant velocity on the highway, then identify the type of motion it has. Because it is the constant velocity on the highway, then it is said to be a uniform motion. Okay, it's said to be a uniform motion. And when you apply a brake to moving bicycle, then what type of motion it is? It is an example of non-uniform motion, because the velocity in that case decreased. Okay, so this is all about your today's worksheet. Hope you understand it very well, and if you really Do so, then complete your worksheet as early as possible. Submit with your teachers. Do like video, share with your friends, and subscribe the channel. Those who have not. Okay, bache, take care. Bye bye.